Hello everyone, welcome to the very first video of the Pandas lecture series. So Pandas is a really powerful data library in Python that helps us to do data analysis and data manipulation on tabular structures of data very efficiently. The two main data structures in Pandas is a series and a data frame. Let us learn about the series data structure in Pandas first of all. In order to do that, I'm going to import the pandas library first into our code, and I'm going to type import pandas as pd and run the cell. We can easily create a series in pandas by using the series method, and in order to do that I'm going to type pd dot series with s capital, and let's see what all arguments can we pass inside the series method. And as you can see, the first argument that we can pass is data, the second one is index. Okay, I'm going to pass the first argument just by typing the argument name, which is data equals, and in the form of a list I'm going to provide some data. So the data can be numerical values, strings, maybe both. So I'm going to give a mix of both strings and numerical values. Let me provide a few names, maybe like John, Andrew, Steve, and let me provide some numerical values as well. So maybe 12, 50, and 23. Okay, I'm gonna run the cell and see what happens. Okay, so we have the data points in this format here, and as you can see, we have an index for corresponding to each value that we have given inside the data, right? So by default the first index is 0, then 1, and so on. So the number one factor that differentiate a pandas series from a numpy array is that we have index labels for series, right, as 0, 1, 2, 3, and etc. So the best part is we can actually give custom index labels for this as well, and in order to do that I'm gonna see the second parameter or the argument that we can pass inside this method, which is index. And for index I'm going to pass a separate list, and I'm going to give a separate index for each of these data points, and for maybe like a, b, and f. Okay, let me run the cell and see the output. And as you can see, now we have custom index labels for each data that we have provided. Awesome. The index values can also be numbers. For example, I'm gonna change this and give 1, 2, 3, 4, 5, 6, and run the cell, and we have the custom index labels as numerical values as well. So we have 6 data elements, and corresponding to that we have 6 index values that we have provided, right? What if I add one more index and create a mismatch in the number of elements? So let's see, and it gives an error saying length of values does not match with the length of index. So always provide index for the values available in the data. Okay, fine. Let me just quickly copy this into a variable, maybe sr1. Okay, and let's see what is inside sr1. Run the cell, and we have the series. Let me go ahead and create a dictionary with maybe a few places and the average heights of men at that place. So maybe for example d1 equals to, I'm gonna give USA, and the average height maybe I guess, or I'm gonna give a random guess. Okay, so maybe 5'10". Okay, and then maybe Africa, and corresponding value to the k is maybe 5'11". Okay, then India with I guess it's 5'7". Okay, and then maybe China with I don't know, maybe 5 6. Okay, so now we have 6 countries or 6 places with the average height of men. Okay, so this is the first dictionary, so the key and the corresponding value of the key. Okay, now what I'm going to do is I'm going to create a new series sr2, which is equal to pd dot series, and as the data I'm going to provide the dictionary. So I am passing d1 and run the cell, and let me see what is inside sr2. Okay, and now we have as you can see, the key inside the dictionary is automatically considered as the index, and the value corresponding to each key is given as the data for each index labels. So that is another way to create a series. Now what I'm going to do is I'm going to create a new dictionary, maybe d2 equals, and I'm going to copy this value and make a small change to it, and I'm going to replace China with maybe Korea this time, and let the height be 5.5, I mean 55, and I'm going to run the cell, and I'm going to type I'm going to make a new series sr3, and it is equal to pd dot series with this dictionary as with this dictionary as the data, which is d2, and see what is inside sr3, and we have we have our new series with this value updated as Korea with 5.5, and what I'm going to do is I'm going to perform an action on these two series, which is sr2 and sr3. So I'm going to add sr2 and sr3 and see what happens. We have a new series which looks something like this. So what happened here is the values with the same indexes got added, or the action was performed on those particular values, and the key that do not match, which is Korea and China, have an output as not a number. So that's how operations are done on a series. For example, I hope you guys remember how to make an numpy array, right? I'm gonna quickly go and make a numpy array by importing the library first. Import numpy as np. Then I'm gonna create an array by using the array method. So I'm gonna create an array variable arr equal to np dot array, and inside that I'm going to provide data in the form of a list, and I'm going to provide 2, 5, 7, 9, and I'm going to run the cell, and we have an array created, a one-dimensional array created. Cool. And what I'm going to do is I'm going to create a new series. Let it be sr new, which is equal to pd dot series with the s capital, and I'm going to provide this array as the data. And when we run the cell and see what is inside sr new, we have a series created with the data in the array as the data of the series. So we can pass data inside series in the form of list, an array, and even dictionary. Okay, cool. So these are the ways in which you can create a pandas series, so that is all for this video. We'll continue with more features of series and other data structures in pandas in the upcoming videos. So stay tuned and take care. Bye.